Okay, so our objective today is to identify and use reflections and lines of symmetry. So our first vocab word is reflection, and this is a transformation.
Oh, you writing down?
I am. That creates a mirror image. Our second one is line of symmetry. This is the line the original figure is reflected over. Okay, so our next group is we're filling in the blanks. So properties of reflection. The reflected image is congruent to the original figure. So the word you're going to put there is congruent. Or you can use our congruent symbol. The original, the orientation of the reflected image is reversed, is the second blank. So reversed. And the third blank is the line of reflection is the perpendicular bisector. Okay, so we talk about congruent. So what does it mean to be congruent? Equal, right? So we have the same size. So our triangle here in the original and our triangle here in the image are the same size. Our second one is the orientation of the reflected image is reversed. Well, you pick one of your angles. So here I'm looking at this one, and you see now it's facing the opposite direction. So it's been reversed. And then our third one is we see that it is a perpendicular bisector. What does it mean to bisect?
Divide, split in two.
Yep, split in two even spots, right? So you see here that our line of reflection causes all of these lines that are conjoining the vertexes of our two triangles to be bisected. So you see that each of them have a tick mark that represents the one on the other side. So for this group, we are talking about reflecting. So what you're going to do is you're going to take your mirror, so your red mirror, or you can eyeball it, but since I have the mirrors out, you can use them, and you're going to put them on our line. So you see that there's a line. You're going to take that beveled edge, so the one that has the indent, and you're going to put it on your line. And then you're going to see the reflection on the other side. When you see the reflection on the other side, you're just going to draw it in. The beveled edge is the side that has like the indent. So yep, that's that one.
So I draw the E?
So you're going to draw the E, but on the other side of the line where it's been reflected. So we're going to draw it on this side. So if you look through over here, see how it's reflected over here?
So I draw it on this side?
Yep.
My E look cute.
So we're going to draw that in.
I got a thick E.
My E thick.
Look at it.
My E.
My E is thick. Let me show you.
She's not right-handed.
A little bit better than mine. Now if you move to the next one and you put your mirror again on that line, you see that it is reflected to the other side. So if you look through here, you should be able to see.
Oh, yeah. Okay. That's a little bit messing with my eyes.
I can't do this one. Why are you doing this?
Okay, so if you do your last one, for Mario, we'll do bubble letters.
Yeah.
Be nice.
See, that's not a bad E.
Example 1 says, tell whether the gray figure is reflected or a reflection of the black figure. We really can't tell which one was supposed to be gray and which one was supposed to be black. So let's go with the top one is the gray one and the bottom one is the black one. So we want to see if they are a reflection. So it tells us the checkpoints, right? So is the image congruent to the original figure? Are they congruent? Are they the same size? Yeah, they are. So yes goes into that blank. The second one, are they in reverse orientation? So are they now, if you pick the vertex that is standing up of this triangle right here, is it in the same direction or the opposite direction in this picture?
Opposite.
It's in the opposite direction, right? Because now it's pointing down. So yes, it is reversed. And then the last one is, the lines connecting the corresponding points, are they perpendicular to the line M? So the way we're going to show that is I'm going to draw lines connecting vertex to vertex, okay? So this one here. So do these lines look like that they are forming right angles with my line M?
Yeah.
Yes.
They do. So it's reasonable to believe that they are perpendicular. So yes goes in that third blank as well. So we can say that they are triangles, or the triangles are reflections, because they meet all the properties. So all properties are met. But the next one we're going to look at is picture B. So are these figures congruent? Are they the same size? Yes. Is the orientation of the image reversed? No. If we drew lines connecting the corresponding points, are they going to be perpendicular to M? I'm going to draw it, but the points are going to overlap, or the lines are going to overlap. So here we go here to here, and here we go here to here. Now we have these two. So we do see that they are perpendicular. So we can say yes there. So why does this not a reflection?
Because it doesn't meet all the properties.
Does not meet all the properties. Okay. And the last question on this page is, name the transformations shown in example 1, part B. So, if this, we did reflections, what is this one?
A slide?
It's a slide. What was the name we called the slide?
I thought it was slide.
Starts with a T?
Translation.
Translation. Nice job. Way to do teamwork. So this is what we talked about yesterday. The translations are the slides. Okay, so which segment is the reflection of segment AB in the x-axis? Which points correspond to A and B? So when we say in the x-axis, we're meaning over the x. So this here is our x-axis. So if you put your mirror on top of your x-axis, which one is it reflecting to? What is the segment's name? So if you put it on the x-axis, so remember that's this one. Which segment is it reflecting to? So we're reflecting it over our x, right?
Mm-hmm.
So if you folded that up, you had your mirror on top of it, where would the segment AB land on top of it? It would land on top of JK. So JK goes right here. So A is reflected onto which point, J or K?
J.
It's reflected onto J, so we're going to put J here. And then what is our coordinate point for J?
-4, -1.
-4, -1. You just got ahead. So now if we're reflecting B, B is reflecting onto
K.
K, and what's our point for K?
-1, -3.
-1, -3. And then the next same question is asked in the next one, except for now, we are now reflecting it over our y-axis. So now we're going this direction. So which segment is Y? If we reflect over the Y, is AB going to be reflected on top of?
B.
ED.
So we have
That's an E.
ED. And then A is reflected on top of which point? D, which has the coordinate of?
4,1.
4, 1. And then B is reflected on top of? Which has the coordinate of? 1, 3. Okay. Are you guys okay with how we got to those points?
Yes.
So we're going to look and see whether the gray figure is a reflection of the black figure, and then tell us the line of reflection. So is the gray one a reflection of the black one?
Yeah.
Yes, and what line is it reflected over?
The x-axis.
Yes, and then we say x-axis. What about number 2? Is the gray figure a reflection of the black figure?
No.
No, right? Because it's just a slide.
Translation.
So it's just a translation. So we're going to say no. And then for number 3.
Yes.
And if we were going to reflect it, which one would it be over?
The Y.
It's going to be over the Y. So if we put our mirror here, if you folded your paper, you would see they'd overlap exactly in the same shape. So we'd say Y-axis. Okay. Okay, so what we have is our square here, and I gave you a Post-it note to represent our first square. So this is A. So how many ways can you fold this directly onto itself so that you have symmetry? So I did one like this. Can you guys come up with any other ways to fold a Post-it note, going back to its original, to have another symmetry? We're not folding multiple times, just one fold from the original.
Fold it in half.
So now you're doing it on your Post-it note. So I want you to figure it out how many you can get. As long as you can fold it from the original with one line so that it completely overlaps to have that symmetry.
Hey.
4, 5. Okay, so what was your first way?
Half.
Just directly in half, right? So I'm going to draw that on here. Obviously, it won't be as accurate as your guys' but so we folded it in half. I know. So our next one, what's another way we could have done it?
The top to bottom.
The other way? What about another way? Any other ways?
Corner.
Corner to corner. And then corner to corner. Obviously that was not a great photo. Hopefully yours looked a little better. Is there any other? Is there a 5th way?
I folded mine like 6 times.
We fold it on top of a fold. So
Are you not supposed to do that?
just coming back to the original. Now that is symmetric how it is. But just coming back to the original. So there is only 4 ways.
Why are you looking at me like that, bro?
Let's be nice. Okay, so here that means we have how many lines of symmetry? We have 1, 2, 3, 4. So we have 4. For B, I don't have a picture for this. Is there any lines of symmetry? How many? No, there's nowhere where I could fold it where it would overlap to be exactly on top of the other one. How about number C?
Yes.
Yes, how many do we have? Take a second and draw yours. We can go corner to corner, so vertex to vertex.
Yes, 4.
And then we have a couple others we can do.
Oh, straight up and down.
We can do straight up and down.
Right.
And we can apply that to each of them.
That was great.
Right.
So, how many lines do we have now? 1, 2, 3, 4, 5, 6.
How many ways y'all done this? Because
What?
The line of symmetry is also the line of reflection. Is this true or false? It's true. So the line of symmetry is the line of reflection. Because remember, it's being bisected when we connect the points. So vertex to vertex, or the corresponding point. The next one is a kaleidoscope example. And we are finding the degree of the angles from one line of symmetry to the next one. So you're finding here to here, here to here, here to here. And so we use this formula of the measure of angle A equals 180 divided by n, where n is the line, or the number of lines of symmetry. So we're going to go to example 1. Okay, so we're going to use that fact that we have the measure of angle A is equal to 180 degrees minus n. So we need to figure out how many lines of symmetry we have in example A. So we have 1, 2, 3. So we have 3. So n has to be 3. So what we're going to do is we're then going to substitute it into our formula. So we have 180 degrees divided by 3. So 180 divided by 3 gives me what value? It's going to be 60 degrees. So what this is saying is that the measure of angles between these are going to be 60 degrees. And it's going to be true the entire way around. And you'll continue to see it. I'm not going to draw all of them. So for B, we're going to do the same idea. And we are going to now count our lines of symmetry. So we have 1. I'll change it out of yellow.
4.
1, 2, 3. Thank you, Mario. We have 4. So that means that n equals
4.
4. So we have 180 divided by 4, which is
40.
it's 45.
Dang. I ain't even using a calculator.
So 45. So that's going to be this distance here. What'd you say, hon? I thought you had said something. All right. Okay, so are you guys okay with this portion? Any questions?
No.
No? Okay.